my dear children. Welcome to the mathematics class. Today we are going to discuss limits and derivatives. In this chapter, we are going to discuss the problems in the exercise 13.2, page number 313 in the textbook. Okay, my dear children. In this exercise 13.2, we have already discussed the concepts and we have already completed 6 questions so far. And seventh question, first seventh Roman, first question also we have completed so far. I hope you have learnt well. I hope you understood well. Okay, my children. Right. Now come to the question number 7, second part. We have already discussed the first part of this question number 7. Now the second part. For some constants a and b, find the derivative of ax square plus b whole square. Okay, my dear children, understood this question? Right. Now let us assume that given function, let y is equal to ax square plus b whole square. We can take this function as f of x or y as per our convenient. Okay, my children, we can take either y or f of x is equal to ax square plus b whole square. Okay, my children, understood this step? Right. Now let us expand this one by using our previous knowledge. If you observe this function, it is in the form of a plus b whole square. Isn't it or not, my children? So let us expand this expression. Okay, my children. Right. This implies y is equal to, where a is equal to x square, b means b only. So a x square whole square, a square plus 2ab, 2 into x square into b plus b. Understood this expansion, my children? By using this algebraic identity, a plus b whole square, or I will take capital letters, a plus b whole square is equal to a square plus 2ab plus b square, where capital letter a is equal to ax square, where capital letter b is equal to small letter b. By using this algebraic identity, I expanded this algebraic expression. Okay, my children, understood this step? Now let us simplify each and every term. Okay, my children. Right. This implies y is equal to. Again, here we have to use our previous knowledge of loss of exponents. Loss of exponents. It is in the form of ab whole to the power of n. ab whole to the power of n. How can you write it? A square. A square. Next, this is x square whole square. I am writing this directly. A square, x square whole square can be written x power 4. Okay, my children, this is the first term. Understood this first term, my children? Right. Plus 2ab, 2ab x square. Understood the second term, my children? This is second term. By simplifying this term, we get 2ab x square. Okay, my children, understood the second term? Plus b square. Okay, my children, that is third term. We got these three terms. We simplified, we expanded this algebraic expression, then we got these three terms. Okay, my children, now we differentiate with respect to x. Differentiating with respect to x. Do you remember this full form, my children? Full form of this short form. Differentiating with respect to x. Okay, my children. Here I am not writing the full sentence. Okay, my children. Right. Then what is a differential operator? D by dx. D by dx of y is equal to d by dx of a square x power 4 plus 2ab x square plus b square. In this step, I wrote the differential operator on both sides. What is the differential operator? Yes, d by dx, because we are differentiating with respect to x. Then differential operator is d by dx. Okay, my children, remember these points, my children. Don't forget. Okay, my children. Right. D by dx of phi. This can be written as, this notation can be written as dy by dx. Okay, my children, d by dx of y can be written as dy by dx. Understood this LHS, my children? Right. Now come to RHS. You have to find the derivative of this function. If you observe this function, there are three terms, namely a square x power 4, this is first term, 2ab x square, this is second term, b square is the third term. So we can find the derivatives of each and every term. Okay, my children? Right. So d by dx of a square x power 4, just like distributive property. Okay, my children, we can take that like that also. D by dx of 2ab x square plus d by dx of by using the distributive property, we get this step. Understood this step, my children? Right. This is equal to, now come to the first term. We are differentiating this function. If you observe this function, here a square is a numerical coefficient because a and b are constants. So a square is a numerical coefficient. So we can write it outside before the differential operator. Before the differential operator d by dx, we can write it outside. A square into d by dx of x power 4. This is the first term. We can write this first term like this. Understood this first term, my children? Right. Now come to the second term. Let us come to the second term. Here we have to find the derivative of this function. Here also, if you observe, 2ab, 2ab is a numerical coefficient because a and b are constants. 2 is also numerical quantity. So 2ab, 2ab into d by dx of x square. Understood this point, my children? Right. Because numerical coefficients can be written before the differential operator. In any term, if numerical coefficient is there, then that numerical coefficient can be written before the differential operator. Then we take the derivative of the remaining part of the function. Okay, my children, keep this point in your mind. Now come to this third term, d by dx of b square. Here we should not use d by dx of x power n formula, my children, because x is not there. This is a constant. B is a constant. So d by dx of constant is 0. Understood this third term, my children? Right. Because d by dx of constant, so by using this derivative formula, we wrote that last term. Understood this last term, my children? Understood this step, my children? Right. This is equal to a square. Now come to this first part, this part, d by dx of x power 4. Which formula is suitable for finding the derivative of this function? Yes, d by dx of x power n. This is in the form of exponential form where base is a variable. Okay, my children. In this case, we use x power n formula. So 4 into x power 4 minus 1, n into x power n minus 1, where n is equal to 4. So 4 into x power 4 minus 1. This is the first term, derivative of this function. Understood this point, my children? Right. Plus 2ab into, here also we can use the same derivative formula, d by dx of x power n, where n is equal to 2. So 2 into x power 2 minus 1. Okay, my children, understood this part? Right. Plus 0, I am not writing this last term, I am leaving that last term. Understood this step, my children? Right. Because d by dx of x power n is equal to n into x power n minus 1. By using this derivative formula, by using this differentiation formula, we wrote these two parts. Okay, my children, understood this one? Right. Differentiation part is over. Now let us write the terms in its simplest form. Okay, my children? Right. A square into 4 into what will get? X cube. 4 minus 1. What will get? 3. Plus 2 2s are 4. 4ab. 4ab x power 1. Isn't it or not, my children? Right. Understood this step, my children? Right. Finally, what will get? 4a square x cube. But in general, we write the numerical coefficient at the beginning of the term. So we are writing 4 at the beginning of this term. So 4a square x cube plus 4ab x, which is the derivative of the given function. Okay, my children, understood? Right. Now come to the next question, that is the third question, third part. In the question number 7, third part. For some constants a and b, find the derivative of x minus a by x minus b. Okay, my children, understood this question? Right. Come to the solution part. Let us assume that y is equal to given function x minus a by x minus b. Okay, my children, understood this step? Right. If you observe this function, it is in the form of f of x by g of x, numerator by denominator. So we use u by v rule. Do you remember that formula, my children? Right. Differentiating with respect to x. So d by dx of y. Here I am writing a differential operator. What is a differential operator? Yes, d by dx. So I am writing d by dx on both sides. D by dx of x minus a by x minus b. Okay, my children, understood this step? In this step, I wrote the differential operator d by dx on both sides. Okay, my children? Right. This implies, see the LHS. How can you write this notation d by dx of y? Yes, dy by dx. D by dx of y can be written as dy by dx. Okay, my children, they understood this LHS. Right. Now come to the RHS. D by dx of u by v, where u is equal to x minus a, v is equal to x minus b. Okay, my children. So we use u by v rule. V into, that means x minus b into d by dx of u x minus a minus u into x minus a into d by dx of v, that is x minus b, whole divided by v square, that is x minus b whole square. Okay, my children, I will write that formula. d by dx of u by v is equal to v into d by dx of u minus u into d by dx of v whole divided by v square, where u and v are some functions in x. Okay, my children, by using this quotient rule, this is also called quotient rule, where u is equal to x minus a, v is equal to x minus b. In this formula, I substituted. Understood this step, my children? Right. Now, x minus b into if you observe this function, we have to find the derivatives of these two terms separately. Okay, my children? So d by dx of x minus d by dx of a. Here there are two terms, namely x minus a. So for these two terms, we are finding the derivatives separately. Understood this part, my children? Right. Minus of x minus a into Again here also distributive property. Two terms are there. For these two terms, we find the derivatives separately. D by dx of x minus d by dx of b whole divided by x minus b whole square. Understood this statement is done? Right. This is equal to x minus b. We write this as it is x minus b into d by dx of x. What is the value of d by dx of x? 1 minus d by dx of a. A means here constant. A is a constant. So d by dx of constant 0. Okay, my children, understood this 0. Right. Minus of x minus a into again d by dx of x 1 minus d by dx of b means constant. Okay, my children. Right. Its value is 0. Whole divided by x minus b whole square. Okay, my children, understood this step because d by dx of x is equal to 1 and d by dx of constant so by using these two derivative formulas we wrote this step. Understood this step, my children? Right. Now let us simplify this part. Okay, my children, differentiation part is over. Okay, my children, this implies dy by dx is equal to x minus b into what will get in this brackets 1 minus 0 1. So x minus b into 1. What will get? X minus b minus, understood this one, my children? This is first term. I wrote directly minus x minus a into, in this brackets what will get? 1 minus 0 1. So x minus a into 1, x minus a only. That is the second term. Understood this is the second term, my children, in the numerator? Right. Whole divided by x minus b whole square. Understood this step, my children? Right. Again let us simplify the numerator part. X minus b minus x, distributive property, my children. Okay, my children? Right. By x minus b whole square. By using the distributive property, minus of x minus a, minus into x minus into minus a plus a. Okay, my children, understood this one? Right. This implies here plus x minus x gets cancelled. Plus x minus x gets cancelled. Then what are the terms left in the numerator? A minus b. A minus b by x minus b whole square. This is the derivative of the given function. Therefore, dy by dx is equal to a minus b by x minus b whole square. Understood, my dear children? Right. Here I am not explaining the question number 8 because question number 8 is same as that of question number 3 in the Roman number 7. In the Roman number 7 means the previous question, same as that of previous question. Okay, my children, will you try that question, my children? Please try that question number 8 by following the same procedure as that of question number 3 in the Roman number 7. Okay, my children? Right. And in the question number 9, also I am not explaining first question because there are only two terms. Find the derivatives of the two terms separately because that function is very simple function. That is why I am not explaining. Okay, my children, try that question also. Try yourself. Will you try the question number 1 in the Roman number 9 also, my dear children? Right. Now, in this Roman number 9, second question. Find the derivative of 5x cube plus 3x minus 1 into x minus 1. Okay, my children, understood this question? We have to find the derivative of this function. Here there are two methods to find the derivative of this function. Okay, my children. First method, by expanding the given function, because it is a product of two polynomials. By using our previous knowledge, product of how to find product of two polynomials, by using that knowledge we make this entire polynomial as a single polynomial. Okay, my children, first that method I will explain that one. And there is another method by using uv rule. This is u and this is a v. You can follow any method. In the examination you can write any one of these two methods. No need to write two methods in the examination. Understood this point, my children? Right. Which method is convenient for you? Which method is easier to you? You can follow. You can write that method in the examination. Both are correct. Both are acceptable. Okay, my children? Right. So, let us assume that y is equal to 5x cube plus 3x minus 1 into x minus 1. I assumed. First of all, we have to assume that given function is y. So, y is equal to 5x cube plus 3x minus 1 into x minus 1. Okay, my children? Right. Now, let us expand. Let us multiply. Okay, my children? Right. This implies y is equal to, here I am multiplying these two polynomials directly. 5x cube into x. What will you get? 5x power 4. Okay, my children. 5x cube into minus 1. Minus 5x cube. Okay, my children. Next to this, by this term, we multiplied this polynomial. Next, what is the second term? Plus 3x. By 3x, we have to multiply this polynomial. So, 3x into x. What will you get? Plus 3x square. Okay, my children. Plus 3x into minus 1. Minus 3x. Okay, my children, understood these two terms? Right. Next, we have to multiply this polynomial by minus 1. Last term. So, minus 1 into x. Minus x. Minus 1 into minus 1. Plus 1. Understood these terms, my children? We are expanding. We are multiplying these two polynomials. Then we got this step. Okay, my children, understood this step? Right. This implies y is equal to, let us simplify like terms. Here x power 4 is there, only one term. We write that to first term as it is, 5x power 4. X cube also only one term, minus 5x cube term. X square term is also only one term, plus 3x square. But here x terms are, two terms are there. Minus 3x is also said to be x term. Minus x is also said to be x term. So let us add these two terms. Minus 4x. Isn't it or not, my children? Yes or no? Yes. Plus 1. Understood this step, my children? We simplified these two terms. Then we got minus 3x. I wrote the remaining terms as it is. So, we multiplied the two polynomials. We got a polynomial here. Okay, my children, we expanded. We simplified. Then, we start differentiation part. Okay, my children. Differentiating with respect to x. Okay, my children. Then what is the differential operator? Yes, d by dx. So d by dx of y, d by dx of y is equal to, hereafter I am writing the numerical coefficient directly before the differential operator. I take only the function in x inside the differential operator. Okay, my children. So 5, I write 5 into d by dx of x power 4. I wrote this first term as 5 into d by dx of x power 4. Okay, my children, understood this first term? Right. Minus 5. Here minus 5 is a numerical coefficient. So we can write it outside before the differential operator. Into d by dx of x cube. Okay, my children, I am writing directly the derivatives of each and every term. Okay, my children, understood? Right. Plus 3 into, here in this term, plus 3 is a numerical coefficient. So plus 3 into d by dx of x square Okay, my children, understood this term. Minus 4x. So minus 4 into d by dx of x. Okay, my children, in this term minus 4 is a numerical coefficient. So minus 4 is written before the differential operator and the remaining part is written in these brackets. In every term we followed the same procedure. Okay, my children, right, by d by dx of 1. So we are finding the derivatives of each and every term separately. Understood this step, my children? Right. How can you write this notation? Yes, dy by dx. dy by dx is equal to 5 into, what will you get d by dx of? It is exponential form where base is a function in x. So x power n formula. We use x power n formula where n is equal to 4. So 4 into x cube. Here also I am writing the derivative of this function directly. 4 minus 1, what will get? Cube, x cube. Okay, my children, understood this first term. Right, minus 5 into, let us come to the second term. Minus 5 into, what is the derivative of this second term? 3x square. N, where n is equal to 3. So 3 into x power 3 minus 1, what will you get? X power 2. Okay, my children, understood this 3x square, right, plus 3 into, what is the derivative of x square? This is also in the form of d by dx of x power n. So where n is equal to 2. So 2 into x power 1, because 2 minus 1 we get to x power 1. Understood this term also, my children? Right. Minus 4 into d by dx of x, standard derivative. D by dx of x is equal to 1 plus d by dx of 1, 0, because it is a constant. Understood this step, my children? Which formulas are used here? D by dx of x power n, d by dx of x power n is equal to n into x power n minus 1. D by dx of x is equal to 1 and d by dx of constant So we used these three derivative formulae. Then we got this step. Understood this step, my children? Right. Now I will write the differentiation part is over. Now I will write the terms after simplification. Okay, my children. Then what will you get here? 5 fours 20 x cube. Okay, my children. This is the value of the first term. 5 fours are 20 x cube. Now come to the second term. Minus 5 into 3 minus 15 x square. That is the second term. Minus 15 x square. Understood this is the second term, my children? Right. Plus, come to the third term. 3 into 2x. 3 2s are 6. So 6x. Okay, my children? Understood the third term? Right. Minus 4 into 1. 4. So this is the value of dy by dx. This is the derivative of this given function. In this method 1. Okay, my children, understood this method? Right. Now come to the next method. I told you previously there are two methods for finding the derivative of this function. In the previous method, we have found the product of these two polynomials. We made as a single polynomial. Now come to the method 2 by using the product rule. What is the product rule? D by dx of uv is equal to u into d by dx of v plus v into d by dx of u. By using this product rule also we can find the derivative of this function where u is 5x cube plus 3x minus 1 and v is equal to x minus 1. Okay, my children, in your mind you have to assume that this entire function is u and this entire function is v in your mind. Okay, my children? Okay. Now come to this step. Let y is equal to 5x cube plus 3x minus 1 into x minus 1. Okay, my children, understood? We have assumed the given function is y. We can assume f of x is equal to 5x cube plus 3x minus 1 into x minus 1. We can assume like that also. Okay, my children? Right. Now differentiating with respect to x. You know that full form of this abbreviation, the differentiating with respect to x. Okay, my children. Right. Then what is the differential operator here? Yes, d by dx. So d by dx of y is equal to d by dx of 5x cube plus 3x minus 1 into x minus 1. Okay, my children, understood this step. I wrote in this step differential operator on both sides. Okay, my children. Right. Now come to LHS. How do you write this notation? D by dx of y means dy by dx. This notation is written as dy by dx. D by dx of y is equal to dy by dx. Okay, my children. Right. Now come to RHS. Previously I told you this is considered as u and this is considered as v. So in this formula substitute u and v. So what is u? 5x cube. 5x cube plus 3x minus 1 into d by dx of x minus 1. This is the first term in this formula. Okay, but it's understood this first term in this formula plus v into what is v? X minus 1. X minus 1 into d by dx of u, that is 5x cube plus 3x minus 1. Okay, my children, understood this step? V means x minus 1 into d by dx of u means 5x cube plus 3x minus 1. Understood this step, my children? Right. This is equal to 5x cube plus 3x minus 1 into, let us use a distributive property because there are two terms are there. So for each and every term we have to find the derivative. So d by dx of x minus d by dx of 1. Okay, my children, d by dx of x minus d by dx of 1. Understood this part, my children? Right. Plus x minus 1 into, see this function, there are three terms. So for each and every term we find the derivative. Okay, my children? When I am finding the derivative of this function, I am writing the numerical coefficient first directly. Okay, my children, what is the numerical coefficient in this term? So 5. 5 into d by dx of x cube. Okay, my children, I am finding the derivative of this first term. So I wrote directly numerical coefficient before the differential operator into d by dx of remaining part of the function. Okay, my children, right. Plus, come to the second term, 3x. What is the numerical coefficient in this term? Plus 3. So 3 into d by dx of x. What is the remaining part of the function? X. So d by dx of x. Understood this part, my children? Right. Minus d by dx of 1. Understood this last term, my children? Right. By using the distributive property, we are finding the derivative of each and every term. Okay, my children, understood this step? Right. This is equal to 5x cube plus 3x minus 1 into, see there I wrote this part as it is. Now come to this square brackets. D by dx of x. What is the value of d by dx of x? 1. Standard derivative. Okay, my children. Minus d by dx of 1. 0. Because it is a constant. D by dx of any number, its derivative is 0. Okay, my children, understood this 0? Right. Plus x minus 1 into, I wrote this x minus 1 as it is. 5 into, what is the derivative of this function? It is in the form of d by dx of x power n. Okay, my children, we use that formula. N into, where n is equal to 3. So 3 into 3 power minus 1. x power 3 minus 1. What will you get? Square. Understood this 3x square, my children. Derivative of this x cube is 3x square. Okay, my children. Right. Plus 3 into d by dx of x 1. Okay, my children. Minus d by dx of 1 0. Understood this step, my children. What is the formulas we used here? D by dx of x power n is equal to n into x power n minus 1 . Next formula, d by dx of x is equal to 1 and d by dx of constant. In this step, to write this step, we used these three derivative formulas. Okay, my children, understood that step? Right. Differentiation part is over. In this step, differentiation part is over. Now we have to simplify. 5x cube plus 3x minus 1 into what we'll get in this brackets 1 minus 0, 1. So, dy by dx is equal to 5x cube plus 3x minus 1. I'm writing directly this one. Okay, my children. Plus x minus 1 into x minus 1 into, in this brackets what you get? 5 3s are 15. 15x square. Okay, my children. Plus 3 into 1 plus 3. Okay, my children, understood this step? Right. Now, let us simplify. Let us find the product of these two polynomials. Okay, my children. 5x cube plus 3x minus 1 plus x into 15x square. What will you get? 15x cube. I'm finding the product of these two polynomials. So, first we multiply this polynomial, this entire polynomial by x. So, 15x cube plus 3x plus we multiply by minus 1. Minus 15x square minus 3. Okay, my children. Understood this step? Right. Then what will you get here? 5x cube plus 15x cube. 20x cube. Okay, my children, understood this one? Right. Next, plus 3x plus 3x. What will you get? So, x square term minus 15x square. Next, x terms plus 6x minus 4. Okay, my children. This is the derivative of this function. 20x cube minus 15x square plus 6x minus 4. Okay, my children, understood this one? Right. Roman number 9. 4 more questions are there. 4 more questions are there. Please try the remaining 4 questions in this Roman number 9. Will you try the remaining 4 questions in this Roman number 9, my dear children? Try yourself, my dear children. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children? Right.